So in this video, I'm going to teach you how to test using the multimeter electronic components. So let's get started, but please don't forget to subscribe, share and like the video because your likes motivate me to create more and more videos for you. I'm sorry for my voice because I'm sick a little bit. Let's get started. So first we're gonna, as you can see here, select the diode option as you can see in the multimeter, okay, and then press the power button. So let's test first diodes. So I have here diodes as you can see here outside the board, and I will show you also how to test diodes inside the board. Okay, so let's begin first with inside the board. Okay, so let's begin with diodes. So for example, let's pick this one, the first one here. So here, as you can see, we have cathode, and here we have anode. So I will put the black probe in the cathode, as you can see, and the red probe in the anode. And I should get a reading in the multimeter, as you can see. I get a reading in the multimeter, okay? So when I swap the probes, as you can see, okay, so nothing in the multimeter, means this is a good diode. So let's check this one also, as you can see over here. So we have here cathode, okay, and here we have anode. So let's put the black probe in the cathode like this, and the red probe in the anode. We should get a reading, as you can see in the multimeter. So if I swap the probes of multimeter, I should not get anything in the multimeter, okay? But for the board, basically, it's not a 100% accurate. If you want to check whether the diode is good or not, you should normally take the diode outside the board, like this one, okay? And check it using the same working principle. We have cathode here, and we have anode here. So if I put the black probe in the cathode, as you can see, okay, and the red probe in the anode, I get the red in the multimeter, okay? So if I swap the probes, as you can see, so no reading in the multimeter, okay? Means this is a good guide. So, but in the board, as I told you before, you can, when you swap the probes, you could get a reading because this diode could be in parallel with other components, like for example another diode or a resistor or a MOS or a transistor, etc. So now let's test the bridge rectifier. As you can see over here, this is basically bridge rectifier, okay? So this bridge rectifier basically is used to make the voltage a continuous voltage, okay? We use this kind of bridges in the switch mode power supply. So to test this component, you should put, here we have minus, here we have plus. The same for this one. We have here minus, here plus, and here we have AC. This 2 for AC, this 2 also for AC. So to test this kind of component, I show you how. So always you should put the multimeter in the continuity option or diode option, and then here we have the red probe of the multimeter. We should put it here in the negative of the bridge rectifier, and the black probe once here, as you can see, we get a reading, and if we move it to other AC terminal, we get a reading, and here we should get a double reading or a simple reading. Means this bridge rectifier is a good bridge rectifier. But if I swap the probes, as you can see, so the black probe here, I should not get anything here, here also nothing, here also nothing. Means this is a good bridge rectifier. So let's check this one also, as you can see over here. So let's put the red probe here in the negative terminal, okay, like this. Okay, and then check the first pin we get already, the second one we get already, the fourth one we get already also. But if I swap the probes, as you can see, nothing here, nothing here, and nothing here. Means this bridge rectifier also is a good bridge rectifier. So let's check these two fuses. As you can see here, basically the fuses are simple to test. To check the fuses, basically it's very simple. Here we have a serviceable fuse, as you can see, and over here we have a bad fuse, a burned one. Okay, so to test the fuse, you should just put one probe of multimeter here and another here, and of course in the continuity option of the multimeter. So let's check. So I should just put one probe here, as you can see over here, and another here, and I get, as you can see here, I should get a very low, as you can see, resistor in the multimeter and a buzzer. Okay, so this is a good fuse. But for this one, let's do the same. One probe here and another here. Nothing in the multimeter. Means this is a bad fuse. Okay, so for the fuse, for example, if you have a bad fuse, you should replace it with another fuse with the same characteristics. So for this one, for example, the characteristics for this fuse, as you can see here, so we have 3 amps, okay, and for the voltage we have 250 volt. So you should replace it with another fuse with the same characteristics. Okay, so 3 amps, 250 volt. So let's check this one also. So also, as you can see, we have 3 amps and 250 volt. So we can replace this bad one with this one. Okay. So for the capacitors, how can we check the capacitors? So we have here basically 3 capacitors that I'm going to show you how to check. So basically this is a bad one, and these 2 are good. So let's check the good one. Okay, you can just always, I work with the same mode in the multimeter. Okay, continuity mode and diode mode. So I can just put one probe here, okay, and the other here, and look to the multimeter. So if I swap, you see, and if I swap the probes, the same thing. So the capacitor charge and discharge. Means this is a good capacitor. But for this one, let's do the same. As you can see, nothing happened in the multimeter. If I swap the probes, nothing. So this is basically a dead capacitor, because a dead capacitor could give a continuity in its terminal or no sign of life. So for this one, for example, this is a serviceable one. So this capacitor basically, as you can see, is for laptop, and also you can find it in the computer or desktop motherboard. Okay, so let's check it. We should get in the multimeter charge discharge. Okay, so let's check. You can see in the multimeter charge discharge. If I swap the probes, you see charge discharge. Okay, means this is a good capacitor. Okay. So for the inductor, here we have, as you can see, inductor. So basically for the inductor is just a wire, as you can see, a wire. So always we can use this mode, the continuity mode, and check this inductor. For the inductor, you should get a continuity and a buzzer, so a very low resistor. So let's check. as you can see in the multimeter, very low resistors. Okay, means this is good. It's not a cathode one. Let's check this one also. As you can see, low resistance in the multimeter and buzzer means this is also a good inductor. Okay, so here basically we have, as you can see here, a component with two diodes. As you can see here, we have its reference MPR 100 CT, as you can see. So basically to check or to test this component easy, because we have two diodes, as you can see, connected together. So we can just test this diode over here, okay, and then test this one also. So let's check. So here we have the anode and here we have the cathode. We get a reading. If I swap the probes, I should not get anything good. And for this one also, here we have the anode and here we have the cathode. We get a reading, and if I swap the probes, nothing in the multimeter, means also this is good. Okay, so for this kind of capacitor, as you can see, you can find this kind of capacitor in the switch mode power supply. Basically this is a protection capacitors or filter capacitors that remove the interference in the circuit. We find always this kind of capacitor in parallel, means it connects the line with the neutral in order to remove and to eliminate the high frequencies. Okay, so to test this kind of capacitors, you should always use, as you can see, this mode, the continuity mode in the multimeter. And this capacitor should never be shorted. Okay, if the capacitor is shorted, means bad. Okay, so let's check. So we can just test these two terminals. Let's put this one and this one. As you can see, now continuity means this is a good one. Okay, let's check this one also. So now continuity means also this one is good. Here basically I have an LED. As you can see, many of my followers ask me how to test this LED. Basically, if you focus here, inside this LED or light emitting diode, we have two parts, this big metal part and this also. So basically this is the cathode. The big one is the cathode and this one is the anode. So we should put here the red probe and here the negative probe. Okay, so let's check it. So the same working principle as the diode. So here I will put the red one and black one here. As you can see, I get a reading. So this is the anode and here cathode. I get a reading in the multimeter. Do you see? So if I swap the probes, so as you can see, nothing in the multimeter. And do you see? The LED eliminated. Okay? Do you see? Here the LED means this is a good LED. Okay? Let's get right now and to check the transformer. So basically the transformer contains many inductors inside it, as you can see. So, and for the transformer we have always the primary winding and the secondary winding. Okay, two parts. Okay, so to check basically the transformer, we should just check using the same mode here, the continuity of this coil. So this is the first one. As you can see, we get a low resistance and a buzzer, so this is good winding or coil. And this one, we get a reading, as you can see, low resistance. This is a good one. Let's check here also. So this should be the first one. So we don't get a reading here. So let's check this one also. We don't get a reading. So maybe the inductor is here. let's check these two. As you can see, low resistance in the multimeter, as you can see, means here these two are one inductor, and these two here should be another one, as you can see. Okay, so we have the first coil, the second, and here we have the two others. This transformer basically is a good transformer. So let's check this one also. Okay, so here we have 4 terminals, and here basically we have 5. We're gonna see. So let's check this inductor. Let's check this one also. So let's check here. Okay. So here we have the first inductor, as you can see. This and this, and this should be the second one, as you can see in the multimeter. Okay. So let's see here also. This is another inductor. Okay, this two. And this is another inductor. So basically these 3 terminals belong to the same inductor, as you can see. Here we have, as you can see in the multimeter, we have low resistance and buzzer, and also this and this. Also this one and this one. Okay, so here we have inductor with 2 terminals, and here inductor with 3 terminals. Okay, so this one also is good. So I will add for you another component. Let's test here this component. This is the Zener diode, as you can see, this one. So basically the Zener diode also contains cathode and anode, as you can see. So this is the symbol for Zener diode, and here we have the symbol for normal diode. Okay, so to check the Zener diode, you should do the same. Just put the black probe here into cathode and the red probe into anode. So let's check. Always using the diode option. Okay, so here I should put the black probe here and the red probe here. I get already in the multimeter, as you can see. If I swap the probes, nothing in the multimeter. Let's check this one also. Here I get a reading. If I swap the probes, nothing in the multimeter. So let's check this one also. bridge rectifier. Basically, the bridge rectifier has as a purpose to rectify or to make the current a DC current or a continuous current. Okay, so the bridge rectifier transfer the alternating current to a DC current. So as you can see, basically the bridge rectifier contains 4 diodes. As you can see, 4 diodes inside it. Here we have this terminal means plus. Here we have basically plus. Here we have plus. This terminal is connected to the capacitor, basically to the filtering capacitor, and here minus, basically we have here minus. Then we have the relay. Okay, so the relay also is one of the main important component in the electronic. Basically the relay contains 2 components inside it, an inductor and a switch, basically an SPST switch, a single pole, single throw, as you can see. So when this inductor are energized, means when we apply a voltage here, the current will pass through this inductor, and then the switch will close it automatically. So that's why we find here in the switch basically 4 terminals or more. Okay, 2 terminals for the inductor and 2 other terminals for the switch. Okay, as you can see here. Okay, for example, if we have here 0 volt DC, the switch will be open, and if we apply a voltage here, 12 volt for example, or 24 volts, the switch will be closed, and then we will get a continuity here, or the voltage will pass. So here we have another component, the crystal oscillator. Basically this is the symbol for the crystal oscillator. Its reference usually is X or Y in the motherboards. Here we have some real pictures of crystal oscillators. So basically this crystal oscillators is always exist near to the frequency ICs. This crystal oscillator gives to the circuit a very specific frequency. For example, here we have 12,000 kilohertz or 12 megahertz. Okay, so these crystal oscillators with the clock generator IC are essential for the synchronization of any motherboard. So without the synchronization, the motherboard components cannot work together. Okay, then here we have the motor. So basically the motor contains inside it a rotor and stator. Basically this is the stator, the fixed part here where we have the inductors, and this is a rotor. Okay, this metal, the turned part. Okay, so basically this is the symbols for the motor. As you can see, we have M here, or this symbol also. Okay, then we have the voltage regulators. We find this kind of voltage regulators in the laptop motherboards or smartphone motherboards. Okay, and of course you can find a voltage regulators with terminals or THT voltage regulators. Basically we have here 3 pins, 1 pin for input, another pin for output, and of course the 3rd pin is for the ground. So input, output. For example, the input is 12 volt, the output is 5 volt. Okay, so this IC regulates the voltage. Okay, then we have the optocoupler. So basically the optocoupler also is one of the main important components in every switch mode power supply. So basically the optocoupler contains inside it 2 components, a phototransistor and a light emitting diode. Okay, as you can see here, for example, for this kind of optocoupler or opto-isolator with 4 terminals, we have here an LED diode that emits the light, and here we have a phototransistor. Basically the phototransistor works exactly as a normal transistor, but for the phototransistor, in its base it did not get a voltage in its base but a light. So the phototransistor is controlled by the light emitted by this diode. We find this kind of optocoupler or opto-isolator in the switch mode power supplies, as you can see here. Basically, the optocoupler controls the output voltage. If the output voltage is not correct, the optocoupler will report that to the IC, to the frequency or to oscillator, and then the oscillator will adjust the frequency in order to get the right voltage. Okay, so the optocoupler control the output voltage. So we have these two kinds of optocouplers. You can find a 4-terminal optocouplers, as you can see here. This is its circuit. And here basically we have a 4-terminal optocoupler, or you can find a 6 or 5-terminal optocoupler. The same working principle. Always you can find an LED diode here, okay, and a phototransistor. And of course here these two pins are not connected. Sometimes you can find that the pin number 6 is connected to the base of the phototransistor. So basically, the diode or the LED diode is connected always to the output of the circuit, and then the phototransistor is connected to the controller IC or the oscillator. If, for example, we should get in the output 5 volt and we get just 4 volt, so the light here in the diode will be decreased, and then the phototransistor will inform the control IC that the output is not 5 volt, it is just a 4 volt. So the IC will increase the frequencies or the oscillation in order to get 5 volts. The TVS diodes. So basically the TVS diodes are a transient voltage separations diode. We called it also a thyristor. Okay, so it is an electronic device that is used to protect electronic circuits from voltage spikes or unexpected voltage changes. A TVS or a transient voltage separation diode may be any directional or bidirectional. As any directional device, it operates as a rectifier that can handle very large peak currents. So as you can see here in the image, basically you can find a TVS with 2 terminals or even 3 terminals. And over here we have its schematic. As you can see, 2 diodes that is connected together, as you can see. So this is its symbol. So the purpose of the TVS diode is to protect the electronic circuits from voltage spikes or unexpected voltage changes. So the power jack, basically the power jack, you can find this kind of power jack in the laptop motherboards. Okay, so the power jack is the input of the power for the motherboard. So basically you can find power jacks with 2 terminals or power jacks with 3 terminals. So basically here the schematic is for a power jack with 2 terminals, as you can see, where we have the plus terminal here in the center, as you can see here, and the negative terminal in the edges. Okay, so of course the power jack is one of the most common faults of every laptop motherboard. So if you get a dead or a failed motherboard, you should always check the power jack, because if the power jack is failed or desoldered, the power cannot get into the motherboard. That's why you should always check the soldering of the power jack. So in the next slide we're gonna see the THD LEDs or light emitting diodes. So we have seen before the SMD diodes. As you can see, you have seen that this is SMD diodes or flat diodes. Okay, and over here, as you can see, we have the LEDs, the THD lead, as you can see. So this is basically a symbol with these two arrows, but here basically I want to identify with you the cathode and the anode in the LED. So always, as you can see, inside the LED here you will find two parts or two terminals. So always the big part here inside the LED means the cathode. Okay, always the big part means the cathode. So the switches here, as you can see, we have SMD switch. This is an SMD switch or surface mounted device, and over here we have a true Hall technology switch with these terminals, as you can see, and basically this is the symbol for the switch. Okay, so here if you focus here, you will see that these switches contain 4 terminals, as you can see, but basically these 4 terminals are just basically 2 terminals, because 2 terminals are connected together and also these 2 terminals are connected together. So these 2 terminals should be connected to the ground and these 2 terminals should be connected to the power rail. The same here also, you will find that these 2 terminals are connected to the ground and the other terminals are connected to the power rail. You can find also this kind of buttons, as you can see basically here. This is basically a single pole double throw. We call this single pole double throw because we have 2 throw here, the through, the C through and the B through, and we have just 1 pole, as you can see. So this is a single pole double throw switch. Okay, so the DC batteries. So basically the DC batteries is easy to understand. It contains just 2 terminals, as you can see, the negative terminal and the positive terminal. As you can see here, this is basically the symbol for a multi batteries. For this we have 2 batteries, as you can see. This is the first one. Here we have plus and minus, and this is the second one, plus and minus. Okay, here in the image we have a 9-volt battery. So the amplifiers. So for the amplifiers, as you can see, basically you can find many types of amplifiers. You can find many types of ICs with 8 terminals, 4 terminals, or even 16 terminals or more. So basically this is the basic symbol for the amplifier, as you can see, with 2 inputs and 1 output. As you can see here, we have 2 inputs and 1 output, and of course here we have the VS plus and the VS minus. Okay, so here, as you can see, always you will find a positive input and a negative input, and here we have the V out or V output. So the BIOS or basic input output system. So this is basically a flash ROM here. This BIOS IC contains a flash ROM or a software inside it. This kind basically of ICs are used in every computer, televisions, tablets, or even smartphones. So basically you can find this kind of BIOS with 8 pins in laptops and computers. Okay, it contains 8 pins, as you can see. So always the first pin here, we have this dot here, or this hole means this is the first pin. We have the chip select. This is the second pin. We have the data output. This is basically the output. Here basically we have the right protect. This is the ground. Always for the BIOS ICs, the pin number 4 is connected to the ground, and the pin number 8 is connected to the VCC always. So the pin number 5, this is the data input. Here we have the clock for the synchronization. Here we have the hold and the VCC in the pin number 8. So how can you check, for example, in laptops, how can you check if the power is good or not in every laptop? So by checking the first pin of the BIOS. So if you plug just the power adapter to the laptop or the battery to the laptop without powering on the laptop, you should find here, or you have to find here, 3.3 volts. So electric lamps. Basically, this is very simple. Here, this is the symbol for lamps or bulbs, as you can see, with two terminals. Okay, as you can see. And of course, there is many types of lamps. So the CMOS battery or complementary metal oxide semiconductor, as you can see. So this is basically the CMOS battery that power the laptop motherboards and the computer motherboards and other devices in order to keep the configuration and the setting always safe. So as you can see here, this is the reference for this battery. Basically, this battery here we have 2032. Basically, this battery is for computers. Okay, and here we have its voltage. We have 3-volt lithium battery. Okay, you can find also this kind of battery, but for this battery, basically, you can find it just in the laptops. Okay, of course, 3-volt. Its voltage is 3 volts. And basically, this is the symbol for the battery with plus here, as you can see, and minus in the other edge. Okay, we have here plus, and the minus is in the back of this battery. But for this kind of battery, of course, we have two cables. The red cable is plus, and the black one is minus. So here, basically, this is a thermistor resistor. So this symbol is for thermistor resistor. As you can see, this is a resistor with this arrow means variable resistor. Here, as we have seen before, this is a single pole double throw switch. We have one pole and we have double throw here. And of course, you can find a single pole 4-through or a double pole double throw or a 3-pole double throw, 4-pole 4-through, 8-through. So here, as you can see, basically this is the symbol for a photoresistor. As you can see, this is basically a photoresistor symbol. Okay, so for the LED diode, the arrows is in other direction. Okay, but for the photoresistor, we have the arrows in this direction. As you can see, means a photoresistor. Basically, this is the symbol for the track. As you can see, the track basically contains 3 terminals, exactly like a transistor. So we have here T1, T2, and the gates. Okay, so this is the symbol for the track. Of course, here we have symbol for resistors. We have seen that this symbol is a US symbol, and this is a universal symbol or a standard symbol that you can find everywhere. So basically, this is the symbol for the IC. Here we have a dot. As you can see, we have this dot here, means this is the pin number 1, 2, 3, 4, 5. Here, this is the analog ground symbol, as you can see. So because there is many types of ground, so this is the analog ground. Over here we have the digital ground. As you can see, you can find this kind of ground in the computer motherboards and other small devices. And here, as you can see, we have the chassis ground. As you can see, this is the symbol for the chassis ground. So we have analog ground, digital ground, and chassis ground. This is basically the milliampere meter symbol. As you can see here, this circle with MA means milliampere meter. This is the voltmeter symbol. We have V here. So basically to measure the voltage in any circuit. So this is the ampere meter. As you can see, we have A. This is ampere meter to measure the current. And here we have the ohm meter. As you can see, we have the ohm here to measure the resistors. But basically you can find that one device can gather all these parameters. Can gather the voltmeter, the ohm meter, ampere meter, etc. The multimeter, using the multimeter or the digital multimeter, you can measure anything you want. This symbol basically is for ceramic capacitor, okay, or this capacitor is not a polarized capacitor. This is a normally open switch. Okay, so here we have, as you can see, basically the wire, and this is a normally open switch. Okay, and here normally closed switch, as you can see. normally closed switch. Here we have, as you can see, the double pole single throw. Okay, double pole single throw switch. Why double pole? Because we have two poles, but we have just one throw, as you can see. Basically, we have one through here. And here, as you can see, basically this is a relay. Okay, here we have an inductor, and here we have a switch. Okay, this is basically a relay, a double pole single throw relay. And over here we have also a relay. As you can see, this is inductor basically. Here we have two switches. So this is a double pole. We have the first pole, the second pole, and double throw, as you can see, double throw. So basically this is a fused, this is a switch, but this switch is a fused switch. So this switch contains a fuse. It is a protected switch. This is basically the DC voltage source, okay? And over here we have AC voltage. As you can see, this is the AC voltage source or power supply. Here we have the adjustable power supply, okay? So basically here we have a power supply or a batteries. So if we add this around, means adjustable power supply. Here basically this is a logic gate. This is the AND gate. Okay, we have two inputs and one output. So this symbol is for the AND gate. And here we have an AND gate, always the same as AND gate, but here we have this circle, means not NAND gate or not AND. Okay, basically here we have the OR gate. Okay, always two inputs and one output, but this is its symbol, as you can see. So if we add this small circle, means NOR gate. Okay, so this is a NOR gate. And here we have XOR gate, as you can see. This is its symbol. Basically here we have a double line here. Okay, we have two inputs and one output. And here this is a NOT gate basically. Okay, a NOT gate. Here basically we have a schematic that gather many components. Here we have a device. Okay, this is basically AC source. Okay, AC source. Let's assume that the voltage here is 230 volt or 220. Okay, and here this is basically a bridge rectifier, 4 diodes. As you can see, we have 4 diodes. Always here we have the anode and the cathode. And here basically we have wires. Okay, so this symbol here, this wire, means we have here no connection here between this wire and this wire. Okay, but here we have connection. Okay, and over here we have the DC. So after the bridge rectifier we get a DC voltage here. Okay,